Animations are a wonderful visualization of what's happening in a physics problem. We also use graphs as a record of what happened during a physics problem that we can look at later. When we look at motion problems, we might make a position graph or a velocity graph. In a position graph, we place the position of the object on the vertical axis and the time on the horizontal axis. When an object has a positive velocity, its motion will move up and to the right. When an object has negative velocity, its position will move down and to the right. In a velocity graph, we place the velocity of the object on the vertical axis and the time on the horizontal axis. When an object has positive acceleration, its velocity will increase. When an object has negative acceleration, its velocity will decrease. If you compare a velocity graph with a position graph, you can find a very special relationship. The velocity graph tells you the slope at each point of the position graph. For example, if an object has positive acceleration, we would see its velocity change from negative to positive. This means that we should see the position decrease initially, then turn around and begin to increase. Reading graphs in this way is an important skill in physics, and our computer code can help us learn how. Let's look at how we can add graphs to our acceleration code with just a few steps. First, we create two graphs, one for position and one for velocity. Then we give Nestor, our marker, two curves in our position graph, one to record his x-coordinate and one to record his y-coordinate. We'll start out only moving Nestor in the x direction, so you can ignore that y-coordinate for now. Then we give Nestor two curves in our velocity graph, one to record his velocity's x component and one to record his velocity's y component. Again, let's ignore the y component just for now. Then, down in the loop, each time we move Nestor, we add a point to each of these curves with his current position and velocity. Running the code shows our graphs growing as Nestor animates across the screen. Let's examine a few scenarios to see how we can read these graphs. First, let's give Nestor zero acceleration so that we can examine constant velocity motion. With a positive velocity, we can see his x-coordinate increase steadily as the animation runs. Meanwhile, his velocity remains constant. If we change Nestor's velocity to a negative value, we see his x-coordinate decrease steadily as he moves to the left in the animation window. Meanwhile, Nestor's velocity remains at a constant negative value. If we add a y component to Nestor's velocity, we can see that the same behavior arises in the x and y components separately. The x and y coordinates change at their own independent rates, matching the values of their velocities. As we've seen previously, accelerating an object can produce some interesting behaviors. Let's give Nestor a positive initial velocity and a positive acceleration, both in the x direction. Notice how his position curve becomes sharper as time increases, since his velocity is increasing. If we make Nestor's velocity negative, we see very different behavior. Nestor begins by moving to the left, but then turns around. This turnaround creates a minimum in Nestor's position curve, and we can clearly see a parabola. Meanwhile, Nestor's velocity curve shows that his velocity is steadily increasing, with Nestor's velocity passing through zero exactly when he turns around. Now let's change Nestor's acceleration to a negative number. He begins by moving left and gets faster in the left direction. Nestor's position curve demonstrates this behavior by becoming steeper, and his velocity curve shows that his velocity is becoming more negative. Lastly, if we change Nestor's initial velocity back to a positive number, we can watch him begin to travel to the right and then turn around. Again, we see a parabola on Nestor's position curve, but this one is upside down compared to the first, since his acceleration has changed sign. Likewise, his velocity is steadily decreasing, changing from positive to negative. If we now give Nestor's acceleration a y component, we can see both his x components and his y components following the same behaviors that we observed when we were looking at one-dimensional motion. This is an important trend to keep in mind in physics. Moving in multiple dimensions works exactly the same as moving in one dimension. You have now learned how to create graphs of animated objects in VPython. The activities in the description below will help you learn more about this process and show you more that you can learn from these graphs.